Sorry about that. So both is negative. I took 7 over the equal sign, it should have been negative. Okay. B, the equation of BE. The equation of BE, that is y is equal to mx plus c. The gradient of BE is change in y but change in x. You all agree with that? Alright, so that would be 4 minus 1 over 8 minus 1. So that will give us 3 over 9, which is a third. You all agree with that? So y is equal to a third x plus c. We will substitute the pointers line on this line, which is b, 8 and 4. That's the x and the y. Okay, so that's going to be 4 is equal to a third times 8 plus c. So that will be 12 minus 8. 12 minus 8 is 4, so it's 4 over 3. Is that correct? In the negative. No, 4 over 3. So y is equal to a third x plus 4 over 3. You all agree with that? So y is equal to the third x plus 4 over 3. Okay, C says prove that AE is equal to AB. AE is equal to AB, which is this line here. Okay? So how do I do that? Distance formula. So I work out the distance of AE, which is going to be x2 minus x1 squared plus y2 minus y1 squared. So AE, so it's going to be 2 minus 1 squared plus 7 minus 1 squared. So it's going to be 3 is 9 plus 36 is 45, so it's 3 root 5. Is that correct?
Yes.
Yes, 3 root 5. So you work out the distance of AB, also distance formula, don't need to write it down again. So 2 minus 8 squared plus 7 minus 4 squared. A calculator, that gives me the square root of 6 squared plus 3 squared. You 3 root 5 as well. Okay, which is therefore AB is equal to AE, which is 3 root 5. Okay, you all agree with that? Then the question says, determine the value of P if it is given that AB is perpendicular to BC. If lines are perpendicular, what do we know? Product of the two gradients is negative 1. So we work out the gradient of AB. Do we have the gradient of AB already? No. Did I work out gradient before? Yes. I don't need to write the formula down again. So it's going to be 7 minus 4 over 2 minus 8, which is 3 over minus 4. Which makes sense, the gradient is lying to the left. Then, the gradient of BC, which is this line here. Yes? Negative 6, absolutely. So that's going to give you negative half. Is that correct? Sorry about that. Okay. Thank you. So you're going to have 4 minus P over 8 minus 5, which is 4 minus P over 3. But what do we say? Points are, if lines are perpendicular, the product of the two gradients, you multiply two gradients together, it must be minus 1. So it's going to be negative half times 4 minus p over 3 is equal to negative 1. I divide by both sides by negative half. So I'll have 4 minus p over 3 is equal to 2. Cross multiply. So it's going to be 4 minus p is equal to 6. So p is equal to negative 2. Okay. Is that correct? Right. Then it says, prove that AEB is parallel to DC. If lines are parallel, what do we know? Gradients are equal. So the gradient of EB. We have the gradient of EB? The third. Do we have the gradient of DC? No. Can we work it out? Yes. Gradient of DC is changing while we're changing it. So it's minus 2 minus minus 5 over 5 minus minus 4. So that gives us 3 over 9, which is a third. Can you see that? So what do I conclude? Since the gradient of EB is equal to the gradient of DC, which is equal to a third. Therefore, EB is parallel to DC. Okay. And then if the question says determine the value of alpha, determine the value of alpha. The angle of inclination of BC correct to 1 decimal place. So that is this angle indicated there. So how do I calculate the angle of inclination? Use tan of alpha in this case. Tan of alpha is equal to the gradient of BC. Do I have the gradient of BC? Did I work out the gradient of BC already? No. So the gradient of BC is changing while we're changing x. So it's 4 minus minus 2 over 8 minus 5. Where this gives us an answer of 6 over 3, which is 2. Not so? So to work out alpha, you're going to say arctan of 2. That gives me an answer of arctan of 2. 63, 4. Is that correct? 63.4 degrees. Because the question was for 1 decimal place. Alright, any issues here? No. That basically brings us to the end of analytical geometry. Okay.